Welcome back to part 2 of section 8.3, equations, quadratic form. In this section, what we're going to talk about is another example. So it takes 2 carpet layers 4 hours to carpet a room. If each worked alone, one could do the job 1 hour less than the other. How long would it take each carpet layer to do the job alone? Okay, so we have a couple variables here. We're going to try to follow the same process. Number 1, read. 2, sign a variable. 3, write an equation. 4, solve. So number 1, we read, and we have 2 carpet layers. That's not hugely important. Here we have total time. This is usually pretty important. So we have total time. Okay, so that's something we're going to take into account to carpet a room. If each worked alone, one could do the job 1 hour less than the other. So then we have another clue here, 1 hour less than the other. So let's say one could do it. I like putting this in terms of, so we have worker 1 and worker 2, number 1, and then we have worker number 2. So for example, if we had, oops, not 12, number 2. So if we had this guy be able to do it in 10, this one could do it in 9. If this guy was an x, this would be x minus 1. Okay, always try to consider a real example first, and that might help you set up a variable example, because what you're looking for is to set up variables. Okay, how long would it take each carpet layer to do the job alone? Okay, so what we want to do is how long would it take to do the job alone? So this is going to be our variable. So our variable here is number of hours to complete the job. Okay. Now, when you're talking about job completion, there's lots of questions like on standardized tests about this, but when we're talking about job completion, it's always like a percentage of the job as you go. What do I mean by that? Well, let's say it takes you 2 hours to do the job. Okay, so then after 1 hour, how much of the job would you have done? You would have half the job done. Then after 2 hours, how much of the job would you have? You'd have the whole job done, 1/1. Okay, so essentially what you can do is you can put the number of hours to complete a job in the bottom. So that will give you how much you can get done in an hour. So if it takes someone 2 hours to finish a job, well, they would do half the job per hour. If it took someone 4 hours to do a job, then after 1 hour, they would do 1 out of 4. So what if it took X hours for someone to do a job? Then after 1 hour, it would be 1/X. So the rate, something per hour, how much the job per hour, is dependent upon how much they can get done for the whole job. So the slower worker, okay, we already determined the slower worker we're going to call X, and then the faster worker we do X minus 1 because he can do it a little bit faster. He requires less time than the other guy. Okay, so our rate. Our slow worker, if he can do the whole job in X amount of hours, then 1/X would be his rate per hour. Faster worker, likewise, would be 1/X minus 1. Boy, did I pick a bad color. Let me try this again. I'll pick dark blue. So we have 1/X and then 1/X minus 1. That is our rate. Now, time working together. This is something that we have. This is our time working together. So we're going to put 4 and 4 here. Now, we can set something up here. We have time working, oh yeah, we have just that one. Fractional part of the job. This is where we multiply these two things together. So we multiply the time working together by the rate, and that will tell you the fractional part of the job that they get done each. So how much the slower worker gets done and how much the faster worker gets done. What happens when you multiply? You get 4/X, and then you get 4/X minus 1. Low battery. We'll get it. These two things need to add up. These, whoops, there's an H there. These add up to whole job. Okay, so those two need to add up to the whole job. Now, what is the whole job? This is something kind of fundamental in these types of problems. The whole job is 1. Just you complete the whole job, 100%. 100%, my goodness, this Apple Pencil. 100% written as a decimal, my goodness, is 1. Boy, I hope you guys get that. Okay, so what we're going to do is we say 4 over x plus 4, oh my goodness, 4 over x minus 1 needs to equal 1. Well, how do we do this here? Well, we have to multiply both sides by the denominator. X times x minus 1. This will get rid of our denominators, and this will help us make this problem a lot more clean. So we have 4 times x minus 1 over x plus 4 times x minus 1 over x minus 1 equals x times x minus 1, because that just stays the same when you multiply by 1. We're going to cancel here. What do we cancel? We cancel the x, we cancel the x, we cancel the x minus 1, cancel the x minus 1, and we don't need to cancel anything there. What are we left with? Well, let me shrink wrap this. Okay, let's move this 100, this disgusting thing over here. Okay, so then we're going to zoom in. Okay, so now we have 4 times x minus 1 plus 4x equals, I'm going to distribute here, x squared minus x. So we're going to have some sort of quadratic because we have x squared. So I'm going to distribute, get 4x minus 4 plus 4x equals x squared minus x. Get everything over to one side. We have 8x here, so I'm going to subtract 8x from both sides, minus 8x. And I'm going to add 4 to both sides. So what happens when we do that? We get 0 equals x squared minus 9x plus 4. Can this be factored? Always check to see if it can be factored. In this case, there's no factors of 4 that also add up to give you negative 9. So guess what? We need to use the quadratic formula here. Not fun, but guess what? That's just how it is. A equals 1, B equals negative 9, and C equals 4. We have our A, we have our B, and we have our C. We have x equals plus or minus, or b plus or minus the square root of b squared minus 4ac all over 2a. That equals b is negative 9, or sorry, negative b. So we have a negative 9 plus or minus the square root of b squared, which is what is that? Negative 9 squared. Minus 4 times A is 1, C is 4. All over 2 times 1. Let's simplify this further. We have negative 9, that's positive 9, plus or minus square root of 81 minus 16. All over 2. 81 minus 16, that should give us what? 60 to 75? 81 minus 16, 65. So we have 9 plus or minus the square root of 65 over 2. Now, if you want to leave it in radical form, that's pretty much good. You're good to go there. I suppose we could write that out as a decimal. So we get 9 plus, we should really separate this in two because we got to remember here we're talking about a word problem. 9 plus the square root of 65. Let's figure out what that number is. 65 square root. Okay, that's 8.06. So 8.06 over 2. That's the same thing as plus 9 divided by 2. So we get 8.5, about 8.53. Or we get 9 minus 8.06 over 2. 9 minus 8.06 divided by 2. And we get about 0.47. So we have two answers here. Or seemingly we have two answers here. So we need to decide which one we're going to use. Now, if we put as the rate for the slow worker 1 over 8.53, that's good. And then that would make the slow worker, then we have fast worker, 1 over 7.53. So those work. What about 1 over the other one, 0.47? The fast worker, 1 over, negative 0.47 minus 1. 0.53. So you can't have a negative rate. So because of that, we're excluding those answers. So our answer here, our rate for the slow guy, is 1 over 8.53. Our rate for the fast guy is 1 over 7.53. And there's our two answers. Okay, we got 2 more problems to go. Hopefully we can finish this up soon so you guys don't have to watch this video any longer. Let's go ahead and get started. So what we're going to do here is we're going to square both sides. We get x squared equals 6x minus 8. Anytime you square both sides, you need to check your answer at the end to make sure it makes sense. Let's get everything over on one side. X squared minus 6x plus 8 minus 6x minus 6x plus 8 equals 0. Can I factor? Yes, I can. Can I factor? Yes, I can. X, negative 4, negative 2. So we get x equals 2 or 4. Is that correct? Well, if we plug in 2, is that equal to the square root of 12 minus 8? Yes, it is. What if I plug in 4? Is 4 equal to the square root of 24 minus 8? That's square root of 16. Yes, it is. So we get 2 good answers there. We're good to go. Now we're on to the last one. X to the 4th minus 13x squared plus 36 equals 0. Anytime you see a problem with this, with x to the 4th and an x to the squared, we can do something called assigning. So we can, assign x squared to be equal to a, and we're going to rewrite the problem. So we're going to substitute that in. We get a, a is equal to x squared, so then a squared would be equal to x to the 4th. So that's a squared minus 13a plus 36 equals 0. Parentheses, we get we get, what is that, 9 and 4? 9, 4, both minus. Okay, we get a equals 4 or a equals 9. Now, here's the deal. We got to substitute it back in. So we're going to put in x squared equals 4 and x squared equals 9. And now we need to solve for x. So we take the square root of both sides. We get x equals plus or minus 2. And we get x, square root, equals plus or minus 3. These are, all 4 of these are our answers. Anytime you have something to the 4th power, you're going to have 4 answers. So we have negative 2, positive 2, negative 3, positive 3. Hope this was helpful. This was a lot of work. Hope it was worthwhile and you learned something today. Until next time, be good, be true, be nice, and be honest. Be good, be kind, be true, be nice, and be honest. And have a great day. See ya.